our online and in-person students, I'm just going to take a couple minutes to answer the first three questions and then talk about the other stuff. So this is on it's in the cards packet worksheet. The first three questions, well, the first one says Mendeleev's periodic law can be stated. The physical and chemical properties of an element are periodic functions of their atomic masses. Atomic masses, yes. Looking at your own arrangement of the element cards, you would not be able to describe this. A periodic function is simply a property that follows a repeating pattern. And we're going to show that in an example of the ionization energy on question number 5 further on down. So let's keep going. Property that follows a repeating pattern. That's what it is. So some of the properties listed on the card are periodic properties and others are not. Name the properties that are periodic functions. So let's talk about which ones are on the card. So if you take a look at this here, hang on, this one here at the bottom, which I did not put on here, it gives you, it shows you what each of these numbers are. So let me show you what the numbers mean. So on the top left-hand corner is what's called ionization energy. It's okay if you haven't heard of this before and you don't know what it is. That's okay. To the right of that is atomic radius. That is the size of the atom, and it's okay if you're not sure what that is. Underneath ionization energy is atomic mass. Next to atomic mass is formula of an oxide. Below atomic mass is formula of the chloride. Next to formula of chloride is the melting point. Below formula of chloride is density. You should know what that is. After that is formula of a hydride. And below density is electronegativity. It's a long word. Okay, so of these 9 properties, this one is a formula, that's a formula, and that's a formula, so we can't use them. Those are not numeric properties. Ionization energy, atomic mass, density, electronegativity, atomic radius, melting point are the 7 that are 6 that are numeric properties. 2 of them are not periodic properties. A periodic property is a property that keeps repeating. The ones that are not periodic properties or show a strong repeating pattern is melting point and density. And you wouldn't know that unless you took a good look at this sheet here. And you would notice that that's melting point, that's density. Notice that they do follow a little bit of a pattern. This one increases and then starts to decrease and then decreases. So there is a little bit of a pattern, but it's not a very strong repeating pattern. That's density, is the green one that I'm circling there. And then this one here is melting point. And it doesn't give us a strong correlation one way or the other, increasing or decreasing, and so on. So those 2 are the ones that we are not going to be using for the graph in question number 5. So melting point, density, we're not using that. So that leaves us with ionization energy, atomic radius, atomic mass, and then the last one at the bottom is electronegativity. And we can also use that one for a periodic function. Okay? So let's keep going. The elements of the binary periodic table are arranged by order of increasing atomic number instead of increasing atomic mass. Why didn't Mendeleev use atomic number to arrange the elements? It seems like that would be a much better way to do it the reason why is because he did a lot of his work in the 1860s I think he died in 1869, which means that he used atomic mass because that's what he had available to him at the time. Wow, did I just screw that up? Mass, there we go. And Moseley did his work, I think that's an E-Y, did his work in the 1930s, I believe. That's where he did X-ray diffraction to figure out the number of protons. Number of protons is, of course, the atomic number. That's what the atomic number is. So that's when they actually started to figure out where the gaps were, although Mendeleev had a pretty good idea where the gaps were anyway, but Moseley really locked the periodic table in place and answered a lot of unanswered questions using his atomic number. Let's move on. So this right here, I want to explain what this is. This is if we were to, come on, you're killing me. This is if we were to, sorry, I got confused there. If we were to arrange all the cards that you saw in class, and if you're an online student, you didn't see these cards at all, but each card here represents an element. And this right here is the atomic mass of that element. And if you look on a periodic table and find what element has an atomic mass of 6.9, you'd be looking at lithium here, and lithium has an atomic number of 3. Okay, so what you can do is I can put the atomic number here like this. This is lithium, but you don't have to label it Li. We can just use the atomic numbers to show what it is. The next one, beryllium, is 9.0. All the way across the transition metals would be boron, which is, of course, atomic number 5. And then there's carbon with an atomic mass of 12 with an atomic number of 6. I'm just going to go straight across here like this. This nitrogen, this tells me oxygen, and I wrote O instead of 8. 9 for fluorine and 10 for neon. And then as we go straight across here, this is where we get sodium at 23 grams per mole, or 23 for the atomic mass, 12 for sodium, not potassium, that's calcium down there. Oh yeah, sodium, magnesium, duh, and then aluminum. It's after aluminum, silicon. Don't write the, seriously. 14, that's phosphorus. 16 is sulfur. 17 is chlorine. And 18 is argon. Wow, that was really tough for me to say the name and then write the number down at the same time. So this finishes up here at 19 for potassium and 20 for calcium. Now that we know what each of these cards mean, we can use the numbers on here. Remember, the top one is ionization energy, that would be the 520. The 0.16 is atomic radius. The 6.9 is mass number. And then we have our formulas, and then at the bottom here we have electronegativity. Those are the 4 that we want to focus on. Let's go on to the next part here. It says, using the possible arrangement of element cards, pick 2 of the numerical properties of the elements that are periodic and plot their values in the graphs below. So I'm going to do this first one very quickly because I've already gone over my time. Actually, I'm going to stop here, and then I will do number 5 example completely by itself on its own screencast. And then I'll talk about what's left in the packet. Okay, so I'm going to stop here, and we'll pick it up from here.